Hi, it's still Thanksgiving weekend. This is Ken Eklund. I'm at home watching some cool videos on YouTube, and I'm not a physicist, but I have an interest in some of these videos because I don't really believe that time can change. I'm still a believer that light is what can change, and there's a lot of evidence that light does change, like this video right here. Let me start this.
So in this video, I thought I'd address a common one and give a correct explanation for why light slows down in water. Actually, that's just a catchy title. I want to tell you why light slows down in any transparent medium, certainly water, but also glass, plastic, and even air. If you ever took a physics class, you learned about the index of refraction of a material.
Okay, that's just the. He explained that later, and he did a great job. Uh, it's like wait, I'll move it up. It's way over here, and it's about waves when they hit the plastic. I think the colors all have their own wave, and then it makes a slower wave.
But slower. So let's get back to light moving through. Super important. So let's just take a careful look at it. If we add the two top waves, which have different speeds, the bottom wave also moves, but slower.
Okay, that's an explanation that I can understand for why the light slows down. Physicists are always saying light is a constant. Light is a constant. Light is a constant. But it slows down in different mediums. So like check this out, and it slows down by a lot. Listen.
Index of refraction equal to 1.5. That means that light will travel at 2/3 the speed of light in the glass. If you shoot a laser at the glass, the light from the laser will travel at the speed of light until it hits the surface of the glass. When it hits the surface of the glass, the light will slow down to 2/3 its original speed, and it will change its direction. Once the light gets to the other side of the glass, it will emerge from the glass, change its direction, and move again at the speed of light.
Interesting, isn't it? So when it comes out of the glass, the waves they're no longer changed by the glass. They go back to the way they were up here, uh, and that's why it goes back to the speed up here. But through here, it's 1/3 slower. That's a huge amount. A huge amount. It's going so much slower here. And all these physicists are talking about trying to measure light, like tiny differences, tiny different speeds, like point and then 20 zeros. It's but but look at this. It's a huge amount, and so it just makes me wonder, uh, because in general relativity and special relativity, they don't like. They keep saying that these thought experiments are. You have to you have to imagine that the speed of light is an unchanging, constant thing. Uh, so this doesn't help me believe in relativity, but this might. This is what I'm going to study next. This is an atomic clock used in GPS, and this goes in a satellite that goes in outer space. So, like if this is the Earth here, uh, there's someone standing on the Earth. This is the atmosphere. Out here, there's a satellite with a clock in it, an atomic clock. It's going really fast. So it's affected by special relativity. So per day, it would go 7 microseconds slower due to special relativity because it's traveling fast, and the clock moving fast slows down. But it's also affected by general relativity, they say, because it's outside or farther away from Earth's gravity. Then it would actually go faster. It would go 45 microseconds faster per day. So they subtract the 7 from the 45, and they come up with 38 microseconds faster per day. So they have to slow it down 38 microseconds to sync it with the clocks on Earth. And because of this, they say it's proof of general relativity. Um, that I have to study some more because uh, what I'm still thinking is that it could be environment, because they could send this atomic clock up into space, and it's going to be affected by weightlessness, the cold. Um, uh, it could be affected by a lot of things, and that could change it. For instance, if you set a wind-up clock into space, let's say this has a spring in it, a metal spring, is it going to be affected by general relativity, or is it just going to be affected by the environment? Same with this. This is an hourglass, sand pouring down through here. You launch this into space, because of their physical characteristics. Um, they may, give different times, but not because of general and special relativity. That's what I have to. That's what I'm going to study next. That's all very interesting.